So hello everyone. So today I'm going to teach you about to find out the unknown resistance of an ohmic resistor by Ohm's law. So we all know that Ohm's law is a relation between the potential difference and the current flowing through a conductor. That means the potential difference is directly proportional to the current, and from these relations you can find out what is the resistance of a particular resistor. So for this experiment you need a battery or a power supply, one ammeter, one voltmeter, one rheostat, that means variable resistor, and two-way keys. So this is the circuit diagram of Ohm's law. So this is the power supply. So the positive terminal of this power supply you have to connect with the positive terminal of the ammeter, and the negative terminal of this ammeter you have to connect to the positive terminal of this voltmeter, and the negative terminal of this voltmeter goes to the rheostat, and from this rheostat you have to connect the two-way key, and from two-way key you have to connect to the negative terminal of the battery or the power supply. Now the resistance of the resistor, which you are going to find out the resistance of the material, so you have to connect parallelly with the voltmeter. So this is the resistor R, which you are going to find out the resistance. So this is all about the circuit diagram of the Ohm's law. Now what you have to do, you have to vary the potential difference between the 2 points or the 2 ends of this resistor, and simultaneously you have to collect the current value. That means what is the current actually flowing through this resistor. So how can you vary the voltmeter reading? So you can change the value of the potential difference between these 2 ends of this resistor with the help of a rheostat, right? So this is all about the Ohm's law. So this is the circuit diagram which we have fixed to find out the unknown resistance of a resistor with the help of a Ohm's law. So you can see this is the voltmeter, and this is the power supply, which we can vary from 2 volt to 12 volt. See, you can see, so you can vary it from 2 volt to 12 volt. So for this experiment we have fixed it to 2 volt. You can see it is fixed to 2 volt, and if you want to increase the power of the battery, you can fix it in desired values for 2, 4, 6 volt, whatever you want. So this is the positive terminal of the battery. So this positive terminal of this battery you have to connect it to the positive terminal of the ammeter, and you can check the value of the current of this ammeter, and the negative terminal of the battery, negative terminal of the ammeter goes to the positive terminal of the voltmeter, and negative terminal of the voltmeter you have to connect it to the rheostat. So this goes to the rheostat, and from this rheostat you have to connect this rheostat to the two-way keys. So this goes to the two-way key, right? So from this two-way key you have to connect to the negative terminal of the battery. So this goes to the negative terminal of the battery. Now the resistor, that means which you are going to find out the resistance of a resistor. So we are basically using a long wire to find out the resistance. So we have fixed this wire parallelly to the voltmeter, as you see. This wire having a definite length. So first you have to find out the length and the cross-sectional area of this wire to figure out the resistivity if you want, and this must have to be connected to the positive and negative terminal of this voltmeter. So this is basically a parallel connections, right? And you can change the value of the potential difference of this of the two end of this wire with the help of this rheostat. And you have to check the simultaneous current value in this ammeter. So you just change the potential difference of this resistor with the help of this rheostat, and simultaneously you have to collect the current value. So this is the observations of the experiment. So this is the voltage. Voltage we have to vary from suppose in our case, so we have varied from 2 volt to 12 volt, and simultaneously we have collected the current in the ammeter. And from Ohm's law, since we know that Ohm's law is basically V is equal to IR, so from this Ohm's law we can find out what is the value of the resistance. So this is the values we have collected from our experiment. So we have to plot a graph between voltage and current, and from that graph we can find out what is the resistance. So this is the graph between the current and voltage, or we can say this is the IV characteristic of the material or the wave. So in the y-axis we have plotted the current values, and in the x-axis we have plotted the voltage values. So what you have to do, so we have to put the current values according to their corresponding. So you have to put here the current values corresponding to the voltage or the potential difference between the two ends of the resistance. So these are the points which we have collected from our experiment. So you see, so this is basically a straight line. So we can say that that Ohm's law is basically a linear equations, and from the slope of this straight line we will get the resistance. So for this we will draw projections from any point on the straight line to the x and y axis, and the difference between the ratio between these current values and the voltage values. So from this ratio, so we will get the resistance of the material. So this is the calculations of our experiment. So from the slope of I and B graph, we get the resistance of the material is equal to 1000 ohm or 1 kilo ohm.